Okay, I would now like to continue with enabling multiplayer VR presence. So last time we created an entity for a spawn point with a position for the location. We passed the spawn point to the channel join from JavaScript to the channel socket. We're not doing anything with it in the backend yet, but in order to stash it so we can query everyone's location and broadcast it out with our own timing, we need an Ets table. So we need a process to own an Ets table. So the way we did this before was we would have a registry. So let's go to our application. And here we have something that's called the experience registry and an experience supervisor. So I think we can probably repurpose these. Maybe we should call this the space registry and the space supervisor. So let's bring up the experience registry. Okay, that is not a, oh, this is just the name of a module. So we can easily rename this to space registry. And this is just the registry with unique keys. Then we have the experience supervisor. I can bring this up. And that is over here. So, yeah, I guess we could just leave this out here. Let's rename these files. Rename this to Space Supervisor. And this can be called Space Supervisor. And it's a dynamic supervisor. And we'll call this the SpaceServer. We'll rename Experience Server to SpaceServer. And we don't know what kind of struct it's going to hold. So let's just call this a SpaceServer process that holds some data common for a space. And let's just get rid of everything else. Okay, the client interface is start. It's got a via tuple to use the registry. Process, event, dump, state. Just remove that for a moment. Load, experience. Okay, via tuple, we'll use the space registry. Get rid of this back. Okay, start link will give OK and a slug. Okay, get the PID. Oh, given an OK and a slug, it will give back some state which just contains the slug. Here's some handle calls. Handle cast. We'll call handle cast, terminate, shutdown, timeout, terminate, process command. Okay, so it's an empty server here. But in our space supervisor, we will allow creating new space server. When we say start space with a slug, and we can stop space, so we'll get the space server. Okay, So that gives us and then in our application we're starting it with SpaceSupervisor. Okay, so now we have a supervisor, and we could call and create new space servers. Let's play around with this in the console. So let's go let's add some things here. So we have space supervisor, space server, right? So going into SpaceSupervisor, the command to create a new server would be to start the space. So we would say SpaceSupervisor dot start a space given a slug, and that gives us a PID. Okay, so that part works. So we now have an owning process for an Ets table. So that one is done as well. Now we need to create an Ets table to store data. So inside the creation of the server, let's rename this file. Rename this to be SpaceServer. What is experience? This is okay. This is I don't think we need this. Delete this file. Clean this up. Game state. Game. Clean these up. Okay. We'll have a timeout. Okay. Init. Okay. Timeout. Okay, let's set a timeout. Timeout. Time in 5,000 seconds. Actually, so this is in seconds, I believe. So 60 seconds in a minute. How many minutes? Let's do 20 minutes. 20 minutes of inactivity. 20 minutes, 60 seconds, and 1,000 milliseconds. Or is it just in seconds? I forget. See the timeout sections. Timeout. Okay. We want to create the gen server timeout. Timeout is an integer greater than 0, which specifies how many milliseconds. Okay, so this is right. 20-minute timeout. And we need ETS table elixir. ETS new buckets registry. When creating an ETS table, 2 arguments are required: the table name and a set of options. From the available options, we pass the table type and its access rules. We have chosen set type, which means the keys cannot be duplicated. We've also set the table's access to protected, meaning only the process that created the table can write to it, but all processes can read from it. Possible access control public, read-write available to all processes. Protected, private. Ets tables can be named, allowing us to access them by a given name. So this gives us the bucket registry, and insert their lookup. But can they be unnamed? So if I did new this is the name. Let me see how I did it before. So open up let's do a search for ETS new. So, it has a reference, set public. Okay, so let's just use this and put this into the state. What was our old timeout? Timeout was timer minutes 25. Oh, that's even better. Returns in milliseconds, 25. Or 20, or 5. Alright, so go OK. So we'll create the ETS ref is ETS ref. Boom. ETS ref. New member movements, set public, anyone can write to it. And we'll do this. And how are we using ETS ref? ETS ref. Get that and get. So it had some fetching functions. State ETS ref. Okay, after init. And ETS delete from there. Okay, let's look at ETS functions. Delete. Presence new. Delete insert. Okay, so it looks like we can insert a position. Using the ETS ref, this is a space channel, it would put in this data. Okay, so that's what we did before. Grab that. And we'll just make a note of this. Okay, so we have created an Ets table. Now what? Store the user's location in the Ets table. So when we join, we'll put that location in when we connect. Okay, and where does that happen? So here we have the space channel. We're joining here. And we have the params. So we have the location. So we can send to self after join with some position. So how does the space channel actually, so we can get the server, we can call its API using PID. Right, so we can go server. Let's create an easier server, A. And if I call SpaceServer PID A, where's my PID? Via tuple. Okay, yes. Registry was registry. Let's look at the SpaceServer before. SpaceServer. Registry. Okay, local decentralized. Okay, here's the registry name. The registry. On our side, we did the same thing, right? The XR space registry. The XR space registry. When you start a space, it didn't seem to. It just created a new space, unless it just died. Let's see. Dynamic supervisor start child. SpaceServer. Okay, with a slug. Start child and child spec, which is a module and a term. Start child module and then initial arguments. Okay. Stop space is get the child ID and terminate. Okay, starting the dynamic supervisor does not seem to... Okay, can we just say where is? When we start space, we can get OK and a pit. And can we say process alive pit? Okay, so it looks like it died immediately. Could be inside SpaceServer. Okay, so we go in here. Maybe we need to restart. Okay, now it's true. Stop the space. Okay. So if we want to start the space again, and server SpaceServer dot pid for A. Now that works. Okay, just needed reboot. Okay, with the SpaceServer, what should have? Okay, there's no way to get the ref unless we hand back a method that says give us back the Ets Ref. So was there such a method? Yeah. Get Ets Ref, which was doing space call, space slug, save call, and the call, get Ets Ref, return with that. Okay, let's grab these guys. We want these handle calls. Here, if I just say Ets Ref for the slug, do a slug. Can you just talk to the, I think you can just do gen server dot call with the PID of the slug, the request, just get Ets Ref, then it will respond with this reply, I believe. Try again. We'll start the space and SpaceServer Ets Ref. Okay, that works. Okay, so the slug SpaceServer, it started with the slug. So in our space channel, after join, set up the presence tracking. Okay, slug. Okay, remind me what the params are. Let's load up the space here. Localhost. I'll just enter here. Params. So we get spawn point position. Okay, so we don't need that in the channel, we need that in the Ets table. So we can just say after join, stick that after join. And what is this? Params is going to be just send it the params. And after join and params, we're tracking this. We can also do socket. Okay, so this is the response, but the socket can have the slug, right? We don't have anything in the socket right now. So I think we can do socket equal assign to the socket slug, which is the slug. And that way in here we can do Ets Ref equal SpaceServer dot, and let's alias that, alias xr SpaceServer, and we want to get Ets Ref using socket assigns slug. What's going on with this? Call socket push. Stroke socket. Is it this? Or just this. Let me undo. I don't know what this error is. Huh? Oh, maybe it's this. Params is unused. Okay. Params is unused. That's fine. What's the matter with this? Ets Ref equals. Okay. Pump this out. Okay, that's okay. Wait, no. Socket. Push onto the socket. Present state. The call socket push. Struct assigns requires that socket at one is of type atom, not don't know what's going on. Undo. Okay, join space with the params. I want to put the params into the socket. Then so assign. Okay, socket equal assign. Socket. And we need the slug. Or maybe it needs to be like slug and slug. After join, take. Oh. No, I think you put whatever you want in here. Okay, we're still okay. Handle the after join with params. That's still okay. And let's say we'll get the Ets table. So Ets Ref equal elixir SpaceServer dot get Ets Ref with socket signs slug. And how are we going to we're going to push that in the space channel. something like this. ETS insert the Ets Ref socket assigns member ID and so some tuple of data, which can be params. Let's stick it in there for now. So params is being used. Ets Ref get Ets Ref SpaceServer. SpaceServer. I thought there was a link for Ets Ref. It's just called Ets Ref. Okay, that's okay. We'll insert something after you join. So let's see if there's any error. Handle info timeout on SpaceServer. So what do we do here? Handle info timeout. Server timeout. Just give that, I guess. Now what? Let me extend this. 15, 25 minutes is fine. Okay, so let's restart the server. Whoa. Terminating get Ets Ref. Place that get Ets Ref. No process is not alive, or there's no okay. Yes, there's no process that's live because we have to start it in the controller, space controller. So if there is a space, then try to start the server, which what happens if we do close your front end for a moment. What happens if you do SpaceSupervisor, create a space, try to create again. That gives you an error. So we're just we'll call a function start space or nudge space given a space, and define a function for nudge space with the space, and we'll just do space supervisor start space with the space slug, and don't really care what the return value is, right? It's either okay or it's already started. Either case, you'll just you'll have it now. So now let's go here. We'll enter the space. Do we get something red? No. Okay, looks fine. So it looks like we did this, store the user's location in the backend. How do we know that it's right? Well, we can, okay, let's edit this to be a simpler name, shall we? Where's this slug? A, save it. Okay, so now the slug's name is A. Yeah, if you rename the slug, your space doesn't get changed in the registry. You effectively abandon the old one, but that's a separate problem. We're going to enter here. This creates a space if it doesn't exist yet. Then we can go to SpaceServer Ets Ref for A. Store that in something. And how do we query this? So on the old one, you could get lookup with the ref assigns member ID. Can you just look up everything? Tab to list. Table to list. Okay. Ets table to list ref. Okay. Yes, it is stored in there. Okay, so we've done this one as well. Now we want to return the location to the channel. So I don't think we need to do that because we can be the authority of our own location. The point of storing in the Ets table is for the other processes so we can determine when to send it to them, but we don't actually need the server to send it back to us. We're the one that gave it to the server. So this all here should be much easier to do, because the last time I thought we can store the last known position in a local variable to avoid the server round trip before rendering our camera. So we can do that in orchestrator. Here we're taking the token and we're sending the initial spawn point. Find the spawn point. But we can actually do something like this. Find position. Find my position. Something like that. Find my position. And we can do window.sessionStorage dot get item can be position. And what happens if you try to look for something that isn't there? So if we said window.sessionStorage get item position, it gives you back null. So if not position string undefined, then we want to store window. Okay, what is Okay, so let's just serialize this thing. So window session storage set item position be JSON. Do we need to JSON stringify this? Let's do orchestrator dot find, no, what's it called? Find spawn point. Let spawn point equal spawn point. Is that okay? Then we say or window dot session storage set item pause to spawn point, and what do we get back? So window session storage get item pause is that. I don't think a JSON and parse. Oops, it's not helping with that. So we need to do JSON stringify that. Then when we get it back, we'll get this, and then we can do that. Okay. JSON stringify this dot find spawn point. Okay, so if you don't have this in session storage, put the spawn point into session storage, and then, well, let's do this. Find spawn point, let spawn point equal this. And return spawn point. However, else we're going to JSON parse position string and return that. So that becomes find my position. And so this is the value we prefer to send in the spawn point, is this find my position, because that's the last known position, and we don't need it back. We have it. I think we need something to store my position. So when we draw our camera, where's our camera? Camera, which is created in the create scene. We set the camera set target free camera takes the position here, which is vector 3, okay, camera. Okay, so when do we call create scene? Create scene called here, but way after initialize. So we're going to have this early on. So create scene, camera, and let position equals this. Find my position. This will be because it returns a position vector with indexes there, so it will be Babylon vector 3 from array. So if we open up the scene debug layer show, and where's the camera? How do I show? What are the? This is scene.camera active camera. What? Camera. Where's our position? Position. 555. Cool. All right. So I think to summarize, we stashed the position that was given to the backend into an Ets table. We created the gen server and a supervisor to be the owner of the Ets table. And in the front end, we used sessionStorage to store our own position, defaulting to the spawn point if we couldn't find it. Otherwise, just pick up the next location. All right, so thanks for watching.